It's another verify, but we're going to be using the sum and difference identities to complete this one. If you look at your worksheet, we're going to be working with number 8 on the verifying worksheet number 2. We start off with kind of a strange looking identity. It's got a couple of angles inside of sine. That's kind of what we're not really used to seeing that. So if you look at either side, you really don't know which one to work with. Up until today, we really haven't had an easy way to to go through this verification or use this identity. But if you look at the left side, you see that it's sine of 3 pi over 2 plus theta equals negative cosine of theta. Today in class, we looked at the sum and difference identities for sine and cosine. What's on the left side of my equation automatically tells me the one I need to use. I need to use the sum formula for sine of alpha plus beta, which I've included over here on the right side of the equation, or right side of the screen. I've simply copied this out of our formula sheets. If we apply this, we look at the square root of, or 3 pi over 2 as my alpha, and then beta is my simple theta. Theta is still an equation, or not an equation, but it's still a variable, but that's okay. In my other side, you still see a theta. It's there, so that's really not a big deal. So what we're going to do is we're going to kind of walk through this a little bit. The first thing we have to remember to do is simply to plug in what alpha is and what beta is into our equation from the original statement. So we take our alpha, we take our beta, and we plug those directly into the equation. Sometimes this might be a real quick, easy thing. Sometimes I may have to draw the triangles like we did in class. This one actually is one of the shorter ones because there's really no triangles to draw, and I went ahead and did the description for you on the left side, on the right side. Positive 3 pi over 2 is right here. If you start your angle on the original x-axis, go all the way around. That's actually, if you convert that to degrees, that would be 270 degrees. Okay, on the unit circle, it has a coordinate of 0, -1. Now, if you remember, this is called a quadrantal angle because it lands right on one of the axes. And the only way we can really do this one is by remembering the coordinate. I guess the good part about this is that the coordinate for each of the quadrantal angles combined either is 0 and 1 or a -1. One of those three, or two of those three numbers. Because if you added it 0 degrees, it would be 1, 0. If it was up at 90 degrees, it would be 0, 1. At 180 degrees, it was -1, 0, and of course down at the bottom we have 0, -1. Well, that's nice because if you remember from our unit circle that the x-coordinate and the y-coordinate corresponded to a cosine or to the sine, as you see on the screen. So what we've done, we've taken these values. If you look up at your equation, we needed to take the sine of 2 pi over 3. And then we have the cosine of theta and the cosine of 2 pi over 3. So what I've done is taken the two actual angles that we're going to plug in, and I've simply, sine of 3 pi over 2 is equal to -1 because the sine is the y-coordinate here. On the other side, you have cosine of 3 pi over 2. Well, cosine, of course, is the x-coordinate, so I simply found the corresponding components, and we're going to make a substitution. You know, this is just like the other identities, except this time we are going to be substituting numbers in instead of trigonometric identities. This is, in my opinion, I believe this is a little bit easier because you actually get to crunch a little bit of numbers instead of just randomly doing all kind of stuff that you have no idea what you're doing. But all right, so you can see we've taken the -1, I plugged it in here. I've taken the 0 and I've plugged it in here. If you look back at the top, the cosine of theta And the sine of theta, we didn't really do anything with that. So I'm just drawing some lines, and they just kind of you just drop those down. Those don't do anything. All right. Now, if I were to simplify this little equation using the negative 1 and the 0, then you get exactly what we wanted. Okay? Because negative 1 times cosine, it's negative 1, or negative cosine. 0 times sine is 0. So therefore, you just simply have negative cosine of theta. And that's exactly, if we look at the top, that's exactly what was on the left side of the equation, or right side of the equation. So we go down to the bottom. That's exactly what we have.